This is the guided review for stoichiometry. Remember that stoichiometry tells us about the ratio of products to reactants, so we can do math when we are given a balanced chemical equation. This chart is on your periodic table, so feel free to reference it. We also are going to be using that mole to mole ratio when using the coefficients from our balanced chemical equation. That's how we do that mole to mole conversion in stoichiometry. We also are going to use that 1 mole is going to equal molar mass in grams. We see that when we're doing a mass to mole conversion. We don't often use, and we're not going to use that mole to particle conversion, even though that is a part of our diagram here. You are going to also get a periodic table when you're doing this on the test, so have a periodic table handy if you need to find molar masses. All right, so we have a balanced chemical reaction, which is the first thing that we need if we're going to do a stoichiometry problem, so that we know the ratio of everything in our reaction. This first question asks, how many moles of lithium are needed to produce 12 moles of LiMNO4? And so as I'm looking at this, my given is moles of that lithium permanganate. So I've got 12 moles of LiMNO4. This is asking for moles of lithium. So how many moles of lithium? As we look at our chart up here, we're going from moles of one thing to moles of something else. So this should be a one-step conversion. As you're looking at these, you can show your work however you need. I like to write out everything using that dimensional analysis. So starting with writing my given 12 moles of lithium permanganate, and now using that mole ratio, using my coefficients from my balanced chemical equation, number of moles of A needs to equal number of moles of B. And as we are setting up that conversion factor, remember what we want to end up with goes on the top of the conversion factor. What we want to get rid of goes on the bottom of that conversion factor. So we have moles of LiMNO3. We want to get rid of moles of LiMNO4. I want to end up with, my problem is asking me for moles of lithium, and so that's what's going to go on the top, is my moles of lithium. Where do I get the values for that? Well, I'm going to go get those from my balanced chemical reaction. I have 2 moles of lithium to 2 moles of LiMNO4. So this is a 2-to-2 ratio. We can go ahead and do our math. 12 times 2 is 24. Divided by 2, we would end up with an answer of 12. And then my units that are left, because these units cancel, 12 moles of lithium is my final answer. You do need to show work as you are working on these problems, so practice showing work as you are doing the review. Next one, given 20 grams of lithium, how many moles of calcium will be produced? So 20 grams of lithium to figuring out moles of calcium, something else. As we look here, we are starting with a mass. We are ending with moles. So that is going to be a 1-2 step conversion. I've got now I'm going to go through and do my setup, trying to get rid of my current units. So I have 20 grams of lithium. I want to get rid of grams of lithium. Well, what do I know about grams of lithium? My conversion factor here, I have my 1 mole is molar mass. I'm going to need to use that in order to write this conversion factor. So we're using this 1 mole is molar mass, using that conversion factor. Grams are on the bottom, 1 mole of lithium on the top. And where do I find that molar mass? I go to my periodic table, and I'm going to round to the nearest whole, so 6.968. Lithium has a molar mass of 7. There's my first step. I've gotten rid of my grams of lithium. Now, in my second step, I'm going to use my mole to mole conversion. So number of moles of A to number of moles of B. I want to get rid of what is currently in the numerator of my setup. I'm getting rid of moles of lithium. I want moles of calcium, because that's what my problem asked me for. And I'm going to get those values from my balanced chemical reaction. So I've got 2 moles of lithium and 1 mole of calcium in that conversion factor. So again, the numbers are coming from our balanced chemical reaction. I can check my units. Moles of lithium, canceling moles of lithium. So I'm going to be left with those moles of calcium. And I can go ahead and do my math. I'm going to go 20 times 1 times 1, which is 20, divided by 7 times 2, which is 14. And I get 1.428. Let's round to 2 decimal places, 1.43. Then we need our unit, moles, and we need to say what chemical we're talking about. Calcium. So we should have that full unit from the top of our most recent conversion factor. Feel free to pause the video and try this last one on your own. Given 4.5 grams of calcium permanganate, how many grams of lithium permanganate will be produced? So this is a gram to gram conversion, so this is going to be 3 steps. Starting with our given, we have 4.5 grams of CaMnO42. In order to go from mole to mole, I need to go from gram to mole. So I'm getting rid of my grams of CaMnO4. I want moles. And so in order to do that, I'm going to find my molar mass for calcium permanganate. So let's go up here. We've got CaMnO4 2. That's what we're looking at. Calcium is right here. So we have 40 plus manganese, 54.94. So let's say 55, and we have 2 of those, so times 2, plus my oxygens. Oxygen is 16, times, I've got 4 times 2, so times 8. And I'm going to find that molar mass. And I got 278 grams equals 1 mole for that. So that 278 is going to go here into that denominator. I'm at moles of my calcium permanganate. So now I need to go, if I look back up at my chart, I started at mass, now I'm at moles. Now I need to go mole to mole using the coefficients from my balanced reaction. So we've got what we want to get rid of. We need to change from moles of calcium permanganate to moles of lithium permanganate. And I get those values from my balanced reaction. I've got 2 moles of my LiMnO4, my CaMnO4. I only have 1, so that's going to go there. If I was to stop here, my answer would be in moles. I need to get to grams though, so we are going to do, finding that molar mass, 1 mole of LiMnO4. Finding that to grams, I'm going to have 1 lithium, 7, 1 manganese, and 4 oxygens for a total of 126 for that molar mass. I'm going to go through and do my math, multiplying 4.5 times 1 times 2 times 126. That goes in the numerator, divided by everything in the denominator. So dividing by 278 times 1 times 1. So divided by 278, which is 4.079. So let's just say 4.08. And then we need grams a unit, and we need to say what chemical we're talking about. That. All right. Last one, considering limiting reactants. So 12.5 grams of that calcium permanganate is reacted with 3.2 grams of lithium. How many grams of lithium permanganate can be produced? So for this problem, we have 2 starting values, so we're going to have to do 2 parts. Part 1 is we're going to do 12.5 grams of CaMnO4 and we need to figure out, well, how much lithium permanganate will that make? Our second part is going to be starting with our 3.2 grams of lithium and ending in the same spot of that lithium permanganate. Feel free to go ahead and try these on your own. Otherwise, you can work through them with me. So this one is a gram to gram. It's going to be 3 steps. If you want to break the steps up into separate parts, you can. But I've got 12.5 grams of my CaMnO4. I need to get rid of grams and get to moles so that I can then use my mole ratio. We found this one up above, that 1 mole is 278 grams, so I'm not going to recalculate that, times, now we're looking at our mole ratio. Moles of calcium permanganate. In my problem, I have 1. I want moles of lithium permanganate. I have 2. And then that last step is going to be to go from moles of lithium permanganate to grams of that lithium permanganate. We found the molar mass for that lithium permanganate up here as well. That is 126. Then I'm going to go to my calculator and punch that in. So I'm doing 12.5 times 1 times 2 times 126. And then I need to divide by everything on the denominator. That numerator gives me 3,150. And then I'm dividing by 278 times 1 times 1, so by 278. And I get 11.3 grams of lithium permanganate as my answer for that first problem. Feel free to pause the video and try number 2, the second calculation for this problem, on your own. I've got 3.2 grams of lithium. I need to go from grams of lithium to moles of lithium, and 1 mole is molar mass. Lithium has a molar mass of 7 times. Now we're going moles of lithium to moles of lithium permanganate. We use our coefficients. So we've got 2 moles of lithium permanganate and 2 moles of lithium in that mole ratio. And then going from moles of lithium permanganate to grams, 1 mole is molar mass, 126 grams of LiMnO4. And then we are going to be able to go and do our calculations. So my calculations on that, when I go through, you should, as your final answer, get 57.6 grams of our lithium permanganate. So how many grams of lithium permanganate can be produced? Well, I have 2 answers. They both can't be right. So which of these actually answers that question? And however much can be produced, that is the smaller of our 2 options. And so it's not the 57.6, the 11.3 is the maximum amount that can be produced. That's our theoretical yield. And that means that all of our 12.5 grams of calcium permanganate gets used up, and then the reaction stops once we've made 11.3 grams of product. We have more than enough lithium, which is why it gave us a larger number. So what is my limiting reactant? Remember, our reactants are on the left. Well, whatever made that smaller amount, that calcium permanganate is our limiting reactant. Our excess reactant, so this was limiting, which means our lithium, we have more than enough to make in our to use in our reaction, and so lithium is excess. We will have some lithium that is left over. So if we want to sketch a model of this completed reaction, what would we include? Well, we are, and I don't need you to necessarily use the colors on these. I am going to always have product in here. So I'm going to have calcium. It says calcium's a solid, so I'm going to just make it look like a solid there. I'm going to have lithium permanganate. I'm going to have LiMnO4 as well. So I'll make that look like a solid maybe. And I'm also going to have whatever I have excess. I'm also going to have lithium in my product. The only thing that I'm not going to have when I'm modeling this is my limiting reactant, because we used up all of the 12.5 grams of calcium permanganate that we had. We have lithium left over, and we made product, both of our products. There's a review posted on Schoology. Reach out to your teacher with any questions.